So we're doing review examples of parallel lines cut by a transversal on page 14. The reason it says review is because you have seen this before. So this first page is a lot of going over things. First thing I want to talk about is this word transversal. So let's underline that. The transversal is a line that's going to go through two other lines. So not all the time are they parallel. So if you look at this right here, this line that cuts through the two other lines, that's considered the transversal. All right, because it's intersecting with these two lines. These two lines aren't parallel. Now, do you remember that parallel lines run in the same direction with the same slope, so they'll never intersect. So these are marked parallel. See that little marking there? That shows they're parallel, or line BC is parallel to line DE. Okay, this one that cuts through the two, that's a transversal. So the transversal is the one that's cutting through the two. All right, so lines aren't parallel here, lines are parallel. Now, whenever you do this, you create interior and exterior angles. So anything within the lines, let me highlight this. So here are my two lines. These points right here are all inside the lines. I mean, that makes sense, right? They're inside. So when we have these right here, these little corners, these angles that we're looking at, those are all interior angles. So that's really important to catch. Now, anything outside are exterior. So these outside of the lines, they're pushed outside of the lines, up and out. Those are considered your exterior. So this little angle here and here, those are all outside, so they're exterior. Because we're going to use those terms. Okay, now, the other term we need to talk about is called alternate. Okay? Alternate the transversal. They alternate sides of the transversal. So 2 and 3 are considered alternate. So they have to cross over. 1 and 4 are considered alternate. And these are considered alternate interior, where 8 and 5, see how 8 and 5 alternate the transversal? They're alternate exterior. So if you can remember those terms, we see the interior, we see the exterior, and alternate means it crisscrosses. So again, this would be alternate with this. Then we already have a whole bunch of the terms that we understand. So when the lines are parallel, alternate interior angles have an equal measure. So this is one of the facts that we need to know. So alternate interior angles, the measures are equal. That's also the same with alternate exterior. So I'm just going to add that in there. So let's look down and talk about this. So we don't have to get out protractors. We're using facts and markings. Remember the protractor has that little dial that you measure your angles with? So right here, they're showing alternate interior angles are equal in measure. So you have parallel lines. See how they're marked? These lines are parallel. And they are telling us that the alternate interior angles, which are 3 and 4, they are congruent. So here's how we write it. Angle 3, there's your angle symbol. Angle 3 is congruent. Remember this symbol? Equal with the little squiggle on top? That means congruent. We're going to use that a lot. Okay, so make sure you make note of that. And your angle symbol looks like a smashed down L. So not less than, but angle. All right, so I'm using the angle symbol, I'm using my congruent symbol, and we're now writing this. Angle 3 is congruent to angle 4 because they're alternate interior. And then we have another set, angle 1 and angle 2. Now that I'm talking about this, do you guys remember any of this? You don't remember this? It's come up a lot, so we'll talk about this. One of the hints they're giving, I don't always use these hints, but if it helps you, if you draw a Z in the diagram, let me highlight this. See if you can take this and draw a Z. Inside the Z are your alternate interior angles. If you draw a backward Z, which makes my head hurt, there are your alternate interior angles. I don't know that that helps, guys. I just remember that they're inside. So we take away all of this. We look inside the lines, and they alternate the transversal. Okay? So we're going to keep using these terms to help us remember. All right, now, on the back, we talk about alternate exterior. So that's why alternate exterior, alternate interior are the same. Now, these rules are only true for when they're parallel lines. So alternate exterior also equal. So let's jump down here. Again, the lines have to be parallel. So BC is parallel to DE. Here's BC, here's DE. Here's your angle. And when we look, these are the exterior angles. See, they're outside. See on the outside? And 1 and 2 alternate. So angle 1 is congruent to angle 2. And you do have to look at each picture because notice they use the same angle numbers. And angle 3 is congruent to angle 4. Angle 3 is congruent to angle 4. So it's the placement of the angles. So 3 and 4 go together because they alternate. They're on the outside. And 1 and 2 go together. Okay. So alternate interior, alternate exterior. Same angles. Now, here's something that's a little bit different. This is the one that I feel like everyone forgets about. They're interior angles on the same side, or sometimes we use the word, I'm going to put in here, consecutive interior, consecutive. So I'll accept either, consecutive interior. So interior angles on the same side. So we'll call them same side interior angles or consecutive interior angles. They're supplementary. Does anybody remember what supplementary means? The little guy's actually saying it. These angles add to 180, okay? So two angles that add to 180 degrees. Anybody remember what they are called when they add up to 90 degrees? That's complementary angles. So complementary C, 90 degrees, supplementary S later in the alphabet, 180 degrees. Okay, so what are we looking at here? And we're going to explore with this more, but here again we have our parallel lines, right? And then same side, I mean, look, same side interior angles, angle 1 and 2 are same side interior. See how they form that? Now, you can look. We know that 3 and 2 are congruent. Those are alternate interior angles. 1 and 2 add up to 180. So let's talk about why. How many degrees are on a line, guys? If I draw a line, how many degrees are on this line? 180, because a circle is 360, right? Now, if I split this line with a ray, these two angles must add up to 180, which makes them supplementary angles, right? Two angles that form a line, they're called linear pairs, but they're supplementary because it's a pair of angles that form a line, linear. But what I want you to see is these two angles will add up to 180. So if this is 100 degrees, this has to be 80 degrees, right? Now, come back to me up here. Picture this. Let's look at this, and you don't have to scribble all over your paper. These two angles form a line, don't they? How many degrees would angle 1 and 3 add up to? Well, they form a line. Forget everything else. See my line? Angle 1 and angle 3 make that line. Wouldn't that add up to 180 degrees? Okay. Now, this angle 3 is equal to angle 2. So if angle 3 and angle 1 add up to 180 degrees, and 3 is the same as 2, wouldn't 2 and 1 also add up to 180 degrees? Okay, just for an example, if I tell you that this is 80 degrees, then this angle is 80 degrees. What's left for this guy? Here's my line, 180 degrees. This must be 100. So rather than me just telling you this is true, these two angles add up to 180 because they form a line. It's a linear pair. Then these angles are congruent by alternate interior. So then this angle must also be the supplement to here. So these are considered linear pair because they form a line. They physically create this line together. These are just supplementary. They add up to 180. Now we're going to write this differently. They're not equal. So put a little m. Mine's a cursive m. So it's a cursive or italic m, but you can just write m. The measure of angle 1 plus the measure of angle 2 equals 180 degrees. A lot of geometry has its own language. And so instead of having to write out the measure, we use m. You can't add objects. Angle 1 is an object. So we're talking about the measure of angle 1. So the measure of angle 1 plus the measure of angle 2 is 180 degrees. So they're not equal to each other. What other same side or consecutive interiors do you have? You have angle 3 and angle 4, don't you? So these two, the measure of angle 3 plus the measure of angle 4 is 180 degrees. And I feel like this rule with 180, we always forget it because everything else is equal. Now, this works, doesn't it? If this angle, here's my line, if this is 80, wouldn't this be the leftover 100? And since these are congruent and these are congruent, alternate interior, these two also add up to 180. So these are considered supplementary. Now that's not the name of them, but the relationship is supplementary. The name of them is same side interior, whoops, or consecutive interior. And I'll take either name. Okay, good. Last big one, corresponding angles. All right, when something corresponds, it lines up with, it's the same as. So when the lines are parallel, we have something called corresponding angles, and they're also equal. They say they do not clearly indicate where they're located. Some are on the same side, some aren't. So let's just talk about this. There's a lot of corresponding angles. Again, I have to have parallel lines. If the lines aren't parallel, then the angles aren't the same. And what's this called? The one that cuts through the two lines. Do you remember what I called this at the beginning? That's the transversal. So I want to remind you of that again. The line that cuts through the two other lines is called the transversal. All of these relationships only work with parallel lines. Now, they're still the same names, but they're not congruent. They're not 180. So what is corresponding? See how angle 1's in the top left, or wait, top right corner? What are their angles in the top right corner? Angle 2. Can you picture taking this line right here? Take this line and slide it down. Wouldn't angle 1 lie right on top of angle 2? Okay, so they are corresponding angles. So angle 1 not only is corresponding with angle 2, they are congruent because of the parallel lines. Now, what other one is corresponding? Let's look at angle 7. What would angle 7 match with? Well, it's in the top left corner of this cluster. What else is in the top left corner? Angle 8. So do you see that I'm picturing taking this line and sliding it down. So angle 7 is congruent to angle 8. All right, what else do we have? I'm running out of colors. What else do we have? Use this. Well, I have angle 4 that corresponds with angle 3. Do you see how they're both in the bottom left corner? So angle 4 is congruent to angle 3 because they're corresponding. And there's one more set. Angle 5 and angle 6. So I'm going to write down here, angle 5 is congruent to angle 6. Now there's no memorizing and trying to be like, oh, 1 and 2, 7 and 8, because you can label these pictures in any order of the 1, 2, 3, 4, 5, 6, 7, 8. It's the relationship. So do you guys see if we pick this up and put it down, how these angles would lay on top of each other and they correspond? So that's the idea there. Okay, so they have this hint for corresponding. It says if you look at a picture of one corresponding angle and split it up or down on transversal, you'd be where the other one is. That's what I was talking about. Another hint is the letter F. I don't know how the letter F helps me correspond, but see how these are both in the crook of the F. And then if I write an upside down F, which again hurts my head, that lies in the crook. I just think knowing the relationship is pretty helpful. All right, so that is it for these notes, and we are going to start with this worksheet.